Welcome to this custom-tailored deep dive. We are opening today's mission with a seemingly ridiculous question.
Right, it really does sound a bit absurd at first.
Yeah, like, why should you care about a discontinued 3-meter AV cable that originally retailed for $270?
I mean, I get it. But the thing is, the DVIGear DVI-2303-AOC-M HyperLight cable isn't just some discontinued cord.
No, not at all.
It is actually a masterclass in hybrid technology that was engineered for high-security, mission-critical environments.
And honestly, that steep price tag is completely justified by what's hidden inside the jacket. So, okay, let's unpack this. We are looking at a really unique hybrid architecture here.
You mean the physical split between the optical fibers and the copper wires?
Exactly. You've got 4 polyfluorinated optical fibers running parallel to 6 traditional copper wires.
And what's fascinating here is the division of labor. That split is what makes the whole thing work.
Because the optical fibers handle the massive video data payload, right?
Yeah, they transmit up to 4.95 gigabits per second without dropping a single pixel of single-link DVI resolution.
Oh, wow. So if the optical fiber is doing the heavy lifting for the video data, it's kind of like a high-speed train carrying the actual cargo.
That is a great way to look at it, actually.
And then those 6 copper wires must be acting like the dispatch tower, just running alongside it. They handle the digital handshake and standard communication so the devices actually know how to decode that light.
They do, yeah. But they also handle the absolute most crucial part of this hybrid design, which is power.
Oh, right. Because active optical cables usually need, like, a bulky external power adapter to convert electrical signals into light and back again.
Which is a total nightmare for clean cable management.
Oh, I can imagine. But looking at the spec sheet, this cable pulls less than 0.3 watts directly from the DVI source device itself.
Right. It uses that copper line to sip just enough electricity to run the lasers firing data down the optical fibers.
It's just an incredibly efficient, self-contained system. But, I mean, that solves the power problem. Deploying this in the real world presents a physical issue for me.
You're thinking about the bend radius.
Yeah. The specs claim a tiny 2-millimeter minimum bend radius. If we're talking about optical fiber transmitting light, bending it that sharply should shatter the internal glass.
Well, you'd think it would snap. But that is where the polyfluorinated part of the spec sheet comes in.
Wait, so it's not glass?
No, these aren't traditional brittle glass fibers. They are specialized plastic polymers.
Ah, okay, that makes sense.
Yeah, that material science allows the fiber to survive a 2-millimeter bend radius without shattering at all.
Okay, so that flexibility definitely helps, but you still have to fish a notoriously massive DVI head through a narrow wall conduit to install it.
Which you can't really do with standard cables. But the mechanical engineers bypassed that bulky connector problem entirely.
Wait, how?
The main DVI housing is actually detachable.
No way, really?
Yeah. Removing it exposes a micro-connector cross-section that is barely 13.9 by 14.2 millimeters wide.
Oh, wow. So you just attach a specialized pull cover, and you can pull the cable right through incredibly tight spaces safely.
Exactly.
And since it is a plenum-rated cable, it's jacketed in fire-resistant materials, making it legally safe to run through those hidden air circulation spaces in commercial buildings.
Right. And then once it's through the wall, you just click the big DVI heads back on and screw them down.
That is brilliant.
It is. Furthermore, because that massive video data payload is traveling as light rather than electricity, the cable has a brilliantly low RFI and EMI profile.
Meaning it doesn't emit a signal that can be easily snooped on.
Right. It is totally immune to environmental noise from power lines or heavy machinery.
So in a military command center or a government building or even a strict security hospital where you absolutely cannot risk signal interference or data leakage, this becomes the go-to choice.
It really forces us to appreciate the invisible infrastructure that makes our modern high-resolution world actually function safely.
Seriously. So what does this all mean for you, the listener? It means this isn't just some outdated cord.
Far from it.
It is a self-powered, highly secure, hyper-flexible data bridge, perfectly engineered to solve multiple physical and security constraints all at once.
Beautifully said.
Which leaves you with a thought to ponder for the rest of your day. As our daily environments demand increasingly massive data loads right alongside stricter security protocols, take a look at the walls around you right now.
Yeah, think about what's inside them.
Exactly. How much of our future infrastructure is going to secretly rely on these invisible hybrid pathways of light, just masquerading as another dumb pipe?